Hello, welcome to another lesson. In today's lesson, we talk binomial theorem. The binomial theorem states that for any positive integer n and any numbers a and b, a plus b raised to the n is equal to the summation from k to n, k equals 0 to n, of n ck a raised to the power n minus k b to the k. In expanded form, is going to be equal to n c0 a raised to the n b raised to the 0 plus n c1 a raised to the n minus 1 b to the 1 plus n c2 a to the n minus 2 b raised to the 2 plus plus n c n minus 1 a to the 1 b to the n minus 1 plus n cn a raised to the 0 b raised to the n. Now the c here is sometimes read choose, okay? So you can, and it's for the combination. So you could say n choose 0, n choose 1, n choose 2, n choose n minus 1, and so on, right? Or you could say combination. Where now the nc sub k represents the binomial coefficient, and here it says nck is read as n choose k. So n is a positive integer and a, b are real numbers. And k is between 0, strictly greater than 0, and n. It can be less than or equal to n. Furthermore, we can work out n choose k as being equal to n factorial over k factorial times n minus k factorial. Right? Rewritten here, n choose k is equal to n factorial over k factorial times n minus k factorial, if needed. Okay? The good thing is that in our calculators, your scientific calculators may be able to do this without having to go through putting it in this equation. But we're going to show you both ways anyway. Now, a fact that you need to know is that 0 factorial is equal to 1. Right? You just have to know that as a fact. Okay, so let's talk about what this is really saying. Now, from the formula there, we have n choose k is equal to n factorial over k factorial n minus k factorial. Let's talk about what factorial means, just the definition of factorial. So n with this little exclamation sign is read n factorial. What it means, n factorial means that you're starting with n, you're going to be multiplying by the next number below it, and the next number below it, and the next number below it. That's why you say by consecutively decreasing integers until we stop at 1. For example, 4 factorial will be equal to 4 times 3 times 2 times 1, and that's equal to 24. If you had just 3 factorial, it would be 3 times 2 times 1. Or 5 factorial would be 5 times 4 times 3 times 2 times 1. And you would just plug them into the formula to get your n choose k, depending on which one you're asked to find. Okay, now We can also find the binomial coefficient by using the NCR. But now we're going to come back to this formula later on, right? But the NCR button now on your calculator, you have this button on your calculator, right? So suppose we wanted to replace them with numbers like 5, choose 0. Okay, so what you would do on your calculator is press a 5, then press the NCR button, then press 0 and equal sign, and it should output 1. If you were looking at 5, choose 1, you do 5 NCR 1, and that will output 5 on your calculator, or 5 NCR 2, that will output 10, and 5 NCR 3 will output 10 again, and 5 NCR 4 will output 5, and let's change this a little bit, 5 NCR 5 will give you back 1. Now notice here the sort of symmetry in the numbers, right? 1, 5, 10, 10, 5, 1, right? Where have you seen this before? Well, we're looking at the coefficients in Pascal's triangle. We saw this when we reached level 5, right, or row 6. Level 5 in Pascal's triangle, or row 6, would have given you this pattern 1, 5, 10, 10, 5, 1. So this is another way, or a way of working out the coefficients. All right, suppose we were using the formula. You didn't have a calculator now, and you're using the formula based on what you were given, that n c sub k is equal to n factorial over k factorial n minus k factorial. Now, some people might wonder why we use k here. It is the same as using r. So r and k are the same things, right? Just different letters that's put in different formulas, but they mean this exact same thing. So that would be equal to n factorial, k factorial, that would be over k factorial, times n minus k factorial. So let's say we're going to use this formula to find the coefficients at level 5. What you would do, you would start with 5, choose 0, and plug it into this formula, right? So instead of, say, so 5 C0, right, you would work it out as 5 factorial over your k is 0. Your k, your n is 5, your k is 0, so n factorial will be 5 factorial, the k factorial will be 0 factorial, your n minus k all factorial will be 5 minus 0 factorial. So that is how you would work out for 5C0 if you're just using this formula, right? But remember, 0 factorial is equal to 1. So then where you see 0 factorial here, you're going to plug in 1, right? 5 minus 0 factorial is 5 minus 0 is 5. So you're going to put in the 5 factorial here as well, right? So 5 factorial here is 5 times 4 times 3 times 2 times 1. And then under the bottom, under the denominator, have 1, which we use to represent the 0 factorial, and then times the 5 factorial here. That would be 5 times 4 times 3 times 2 times 1. If you notice here, all the numbers in the numerator are the same as the numbers in green here in the denominator. So that means the number in the numerator and in the denominator are the same. So the product will be the same, and so that will be equal to 1 if you divide it up. The next step will be finding 5, choose 1, using this formula. So that would be 5 factorial over, our k was 1, so that's 1 factorial times 5 minus 1 factorial. And so that's going to be 5 factorial over the 1 factorial. 5 minus 1 is 4, so that's 4 factorial. Will be equal to 5 times 4 times 3 times 2 times 1. I'll divide by 1, which is 1 factorial. And 5 times 4 times 3 times 2 times 1. And if you divide these out, or, let's say we divide like terms into each other. The 1 divides into the 1, 2 divides into 2, 3 into 3, that's 1, 4 into 4. So you're left with only 5 over 1. Because notice here, the 4 times 3 times 2 times 1, you divide out the 4 times 3 times 2 times 1 time. 5 over 1, that is equal to 5. Next level, let's look at 5. Choose 2. It's going to be 5 factorial over 2 factorial. 2 was there, k. So whatever is there goes first here, 2 factorial times 5 minus 2 factorial. So that's going to be 5 factorial over 2 factorial times 3 factorial. So then that's going to be 5 times 4 times 3 times 2 times 1 over 2 times 1, which was your 2 factorial, times 3 times 2 times 1, which was your 3 factorial. And now, if you simplify that, you get 10 over 1, and that would be equal to 10. Next level, 5, choose 3. 5, choose 3. So 5C3 be equal to 5 factorial at the top again, then 3 factorial, right, times 5 minus 3 factorial in the denominator. That's going to be equal to 5 factorial over 3 factorial times 2 factorial. And so that would be 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, then times 2 times 1, which was a 2 factorial. If you notice, there are things in the denominator and numerator which can divide into each other once. So at the end, you're going to have 10 over 1, and that's equal to 10. Next step, your 5, choose 4. 5, choose 4, and then that's going to be 5 factorial over the 4 factorial first, and then the 5 minus 4 factorial multiplied together. So that's going to be 5 factorial over 4 factorial times 1 factorial. And so that's equal to written out 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, and then times 1, which was here 1 factorial. And so if you divide out through the numerator by denominator, you end up with 5 over 1, and that's equal to 5. The last one we do is 5, choose 5. And so that's going to be equal to 5 factorial over 5 factorial here, because the 5 goes there again. And then 5 minus 5 factorial, which is going to be equal to 5 factorial over 5 factorial times 0 factorial. Then you write it out, 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1, and times 1. The 1 here is for the 0 factorial. So dividing these out is going to be equal to 1 over 1, which is equal to 1. Again, notice here the coefficients that we worked out, right? Were 1, 5, 10, 10, 5, 1, which was the same as when you use your calculator NCR button, this formula, or the level 5 in the Pascal's triangle. Right, so these methods are just used to find the coefficients, the binomial coefficients. Right? Now, we can now use these methods to now expand binomials. So we have this expand 2x minus 1 to the 4th, and we have this other one, x plus 3 to the 5th, using the binomial theorem. But now we notice already that your coefficients, we worked it out in multiple ways, so the coefficients are what? 1, yes, and then what? 5, and then 10, and then 10, and 5, and 1, right? So these are the coefficients we're going to use and multiply by our terms. So you could let, x, a is equal to x, b equals to 3, and n will be equal to 5, right? From a plus b raised to the n. So that's how you expand it out. All right? And so we're going to use the binomial theorem. And you started out with the highest one, right? So x plus 3 to the 5, fifth power. All right, you're going to start out with the highest one. So that's 5, choose 0. But we worked out these coefficients, so we're going to replace them. But we're just going to write them out. And then remember, when we started, you go a to the n, so that would be x to the n, which was 5, right? X to the 5. And then b, which was 3, and 3 raised to the 5 minus 5. And 5 minus 5, right, which would be 0. Okay, so remember, we always start the first term, it starts with the highest power and then it decreases. All right, the second term starts with lowest power 0 and then increases. Right, so then we're gonna do 5, choose 1, right, and so that would be x, so we're decreasing in the first one, so that's gonna give 4. So notice it goes from 5 to 4, and then the next term will be increasing, so it goes from 0 to the 1. Right, and we're writing all the exponents in order. And then plus, we're gonna do 5, choose now 2. 5, choose 2. Right, 5, choose 2. And so we write the first term, which was x, but now it's going to the third power. So it went 5, 4, then 3. And then the 3 now, which was their second term, 3 now, which was their second term, is going to be going up. So that's going to be going from 1 to 2. And then the next one will be 5, choose 1. And then your x, which is your first term, will be going down. So that's going to be no, I'm sorry. Let's go. This gotta be 3. Right? Are we going up here? 0, 1, 2, 3. So that's going to be x to the second, and then 3 to the first power. We're going right. So that's 5. So that's 0, then 1, then 2. So this would go to the third power. All right, so we're going up, and then a little bit out of space here, but let's continue. 5, choose 4. It's gonna go x now to the first, and then 3 to the fourth power, and then finally 5, choose 5, x to the 0 power, and 3 to the 5th power. All right, so if you notice here, the first term decreases in exponents: 5, x to the 4, x to the 3, x to the 2, and x to the 1, x to the 0. And the second term will be increasing powers. All right, so let's scroll down a little bit down here. So we said that a was equal to x, b was equal to 3, n was equal to 5. All right, and then we look at this because this is in like 2 lines. Notice here you just wrote the 5 minus 1 instead of the 4 right here. But that's fine. In the next line we're going to do that. All right, let's scroll this in a little bit. All right, so the next line is the same, x to the 5th. Okay, so we would have put here the coefficients first. So your coefficients, 5c0, if I could put in a line there, another line right here. Let's put it right in. 5 choose 0 was 1. Right, let's put in it with these coefficients. Right, and then x to the 5th, and then 3 to the 0 power. Right? Let me choose another color for the coefficients. So that's 1 times x to the 5th. So this 1 here is coming from 5 choose 0, which we worked out earlier. X to the 5th is here, and then 3 to the 0. All right, and then plus 5 choose 1. We know that was 5. So let's write the coefficients here. That's 5. Right? And then x to the 5 minus 1 is 4. Then 3 to the 1. And that will just become 3. And then plus 5c, 5 choose 2 was 10. 5 choose 2 was 10, right? And then x to the 5 minus 3, x to the 5 minus, x to the 5 minus 2 rather. So that's x to the 3rd power and 3 to the 2nd power, right? And then we're going to be adding 5 choose 3, that is another 10, right? Another 10, x now to the 2nd power, right? So 5 minus 3 is 2, and then 3 to the 3rd power, 3 to the 3rd power. And then you're going to add 5 choose 4 is going to bring you back to 5. Work that out to be 5. And then x to the 1st power now, and 3 to the 4th power, and then plus 5 choose 5 here is going to be equal to 1, right, 1, and then x to the 0 power, and then 3 to the 5th power. Now, how did this part simplify to just x to the 5th power? 1 times x to the 5th is x to the 5th. But 3 to the 0 is 1 as well. So it'll be 1 times x to the 5th times 1. And that just gives you x to the 5th. This one is 5x to the 4th times 3, because 3 to the 1st power is just 3. Then this is 10x to the cube times 9. So this dot here, we just make it look like a times there. Times 9. Then 10x squared, 3 to the third power is 27. So that's not a decimal 27, that's a times 27. And then 5x to the 1 is just 5x, and then that's times 81. And then this here, 1 times x to the 0 is 1. So that's 1 times 1 times 3 to the 5th power. So that just gives you 3 to the 5th. One more step in the simplification process. X to the 5th is just x to the 5th. 3 times 5 is 15, so that's 15x to the 4th. 10 times 9, that's 90, so that's plus 90x to the 3rd. Plus 27 times 10, that's 270, that's 270x to the 2nd. And then 5 times 81 is 405. So that's 405 times x. And then 3 to the 5th is 293. So your final answer, x to the 5th plus 15x to the 4th plus 90x to the 3rd plus 270x squared plus 405x plus 243. And that is how you would, first of all, work out your binomial coefficients using the binomial theorem and then applying it to the expansion of a binomial. Thank you.